Hi everyone, here we are with our third installment of our network scanner with Scapy. Scapy is an all general purpose module for creating and crafting packets. In Windows, you do have to install it using PIP. We're using Kali Linux for our Linux distribution. Scapy is already, or Scapy is already installed. All right. Let's go from the beginning of our program. We call the main function. The first thing we do is we print, oh, there's our network scanner. So that I don't have to type in my local IP, my local network address every single time I'm testing a program. This is my local IP addressing scheme for my network. Yours is going to be different. How do you find out what your IP address network is? Well, you bring up your terminal or your command prompt, and you would type in our friend IP config/all. In Windows, this gives you all the IP information. This address is for our VirtualBox connection. Never ever use it for anything. It's just there to attach our VirtualBox to our network adapter. Oh, here it is. I have an IP address, 192.168.9, 255.255.255 masks this out. So that makes this the network address. So how I would denote that is 192.168.9.0, because 0 is the network address of our network. /24 means that we have a 255.255.255.0 subnet mask. So I can either input my range, or the default network is placed into my input for me. Well, then I'm going to call my scan function with the IP address range of my network. Let's scooch up here. This gets passed in. I'm going to use the ARP command, and my destination is going to be the IP address range. This is going to be my ARP request. Now my source MAC address is my computer. This is our target IP address. ARP is Address Resolution Protocol. What it does is it determines the MAC address associated with every IP address in this range. If the device is not connected to the network, you will not get a MAC address for that IP address. So this is just the ARP request. Well, we also want to make sure this ARP request is sent as a broadcast. So this is an Ethernet packet with a destination of FFFFFFF. Well, this is the MAC broadcast address. This sends it to everybody. And what we're going to do is combine these two packets together with the Scapy operator, which is a slash. Our broadcast and our ARP request gets put together. So we're broadcasting our ARP request. We get the information back as a list. Two lists, actually. Oh, here, we're sending it. Okay, sorry. This is just our broadcast packet. Here, SRP means we're sending that out and receives packets with the custom layer information we put in. So we are sending it out, ARP broadcast request. We're waiting 2 seconds for a response. If something doesn't respond in 2 seconds, it's not likely to respond. This returns a list of answered and unanswered, according to our IP address range that we put into it. So in this case, to start with, we're going to print both lists. All right, well, let's run this guy. There it goes. There's my IP address range, and it's sending all kinds of stuff, and oh my goodness, look at all that. So this part, the only reason I did this is just to show the process that's going on. So this is our putting together of our broadcast and our ARP request. And it's saying this to everybody on our network. to what is the MAC address. This is what I'm asking. I'm saying, what are the MAC address of all these people? And the reason it's not asking for 1 and 10 is those are devices that our computer already has MAC addresses for, I think. Never noticed that before. So we go through all 256, sending that out to everybody. And this says, oh, there's a MAC address. Ooh, there's a MAC address. Ooh, there's a MAC address. So we're getting all kinds of MAC addresses. Well, that's good. That's what we wanted. We wanted to get MAC addresses from everybody. Well, let's refine this a little bit. This is version 3B. This part's exactly the same. We're scanning our network. In my case, my local network. Yours may be. It's quite often common to have 192.168.1 or 0 here. All right, we're doing the same thing. We're putting together 2 packets, and then we put them together. We send out our broadcast, same thing we did before. However, notice this is gray. We're not going to use the unanswered list. Well, it's a list. So for each element or IP address or whatever you want to say in the list, we're going to print whatever that element is. So we're going to have a little nicer response this time. And there we are. And oh my, well, we got all kinds of things here, didn't we? This is the raw output. Not exactly the most friendly thing that I've ever seen, but it's showing that I have probably 14 people on my network. Here's the packet that went out. Here's the destination. There's the source MAC. Oh, there's the destination MAC address. So you can see there's a lot of information in here we really don't need. Same thing we had before up until here. We're going through our list, our answered list again. Now for each element in our send, we have various parts or pieces or whatever you want to say that we can pull out of each element as we go. And this would be the first part of the list. So in the first element of the 0, 1, we get the PSRC, which is our source IP address. Here's our hardware source, which is the other end. This is the source that's being sent to us because this is the answered list. And then we're going to print those both out. So if we go back to the other one and run this quickly, we can see where that stuff comes from. And there it goes. So, query, destination, PDST. Each of these has, it's not really a dictionary. It's more like an object where we have properties. So we can pull these properties out like PRSC, hardware destination, IP destination. We can pull out the pieces of this that we want. So if I run the other one, I'm pulling out the source address of the answer and the source MAC address of the answer and printing both of them. So I will run it. Press enter, and there it goes. And there we are. There's the source IP address. There's the source MAC address for each device. Not sure why I didn't do this before, but let's put in a little F-string formatting so that we can show this as a little bit nicer list. So you put curly braces around the variables. We start out with F, F, double quote at the end. All variables go inside of curly braces. I just put the dash in there just to make it look nice. Maybe I'll do it this way instead. We'll see. Now they're both printed on the same line and it'll look a little nicer. There's our guys. Source, Mac. Okay, I think it'd look better with a dash. Let's take that out, put in a dash. This guy needs to be longer. Or we don't need it in between every one. Let's just put it up here. Let's just make that 40. Whoops, numlock's not on. All right, let's see if that's more beauteous. We need a parenthesis at the end. All right, let's see what we get. Oh, I like that better. I can see these guys next to each other. They don't line up perfectly, but still, this differentiates between my list of what I want and the rest of the mumbo jumbo that comes out. Well, the next thing is, does this work in Linux? Because I'm not a Linux head, I usually do most of my coding in Windows and then paste it into Linux. One thing to be aware of, that if you're used to using Visual Studio Code and you're used to having your tab, when you press a tab, have it turned into spaces, well, with Nano it doesn't do that. So if you're typing things in manually, and what the PEP 8 says is use spaces, you want to make sure you have spaces, otherwise it's not going to run. Well, there's our program, exactly the same. We do need to run this as sudo. Otherwise it won't run, because we need elevated privileges to get to the networking in Linux. There it goes. Enter my IP address. Sending out the packets. There it is. Works just fine. I'm not sure why, but I got 13 answers from my Linux and 14 from my Windows, but who knows. But it works exactly the same. It's nice to have cross-platform scripts. Well, that's step 3. Step 4 of this little series is going to be cleaning up our output a little bit more.